Okay, so we are going to be talking about molar mass. And molar mass is the mass in any 1 mole of any given compound or element. So let's say, for example, we wanted to find the molar mass of palladium. We have to look at our periodic table and we can see the molar mass is right there in the atomic mass, which is 106.42 grams per mole. So what if we wanted to find something a little bit more complex, like CaCl2? So the first thing that we would need to do is find that atomic mass for Ca. So we have 1 mole or atom of Ca times 40.08 grams of calcium per 1 mole of calcium. So we cancel out our moles and we multiply to get 40.08 grams of calcium. Next we do the same thing for chlorine, except this time we have 2 moles or atoms of chlorine multiplied by that atomic mass, which was 35.45 grams of chlorine per 1 mole. We multiply that together, also canceling our moles out, and we get 70.90 grams of chlorine. Now all we need to do is add the two together because we're trying to figure out the altogether molar mass of CaCl2 to get 110.98 grams per mole of CaCl2. Now let's try something a little bit harder, like C10H6O3. So we go back and find our carbon atomic mass. And so this time we have 10 moles or atoms of carbon multiplied by 12.01 grams of carbon per 1 mole of carbon. So we get 120.1 grams of carbon. Next we do the same with hydrogen, and we have 6 moles or atoms of hydrogen multiplied by 1.008 grams of hydrogen over 1 mole equals 6.048 grams. Now we go back and do the same thing for oxygen as well. See the system. Now we have 3 moles of oxygen times 16.00 grams of oxygen per 1 mole, canceling out our moles, and we get 48 grams of oxygen. So now again, we have to go back and add them all together. See, it's all the same pattern for any type of compound that we could be given. So once we've added them all together and done our sig figs, we get a grand total of 174.15 grams of C10H6O3. And that's how you find the molar mass.